Hello, my name is Josh Cherian, and I'll be presenting a wearable haptic interface for assisting blind and visually impaired students in learning algebraic equations. Algebra is a fundamental mathematical concept. However, achieving fluency can be quite challenging for blind and visually impaired students, as algebraic equations are communicated visually through sequences of specific symbols. Because algebraic equations are communicated visually, BVI students need to commit equations and the steps they take to working memory, inducing upon them a significant cognitive load. As a result, BVI students are slower than sighted students at solving algebra problems. 75% of BVI students are more than a full letter grade behind sighted students in mathematics. 20% of BVI students are 5 or more letter grades behind sighted students in mathematics. To address these issues, we utilize haptics. Haptics offer a means of communicating algebraic expressions to BVI students through a new sensory medium which can help lower the working memory associated with solving algebraic expressions. In this work, we aim to answer the following research questions. What is the ideal configuration of vibrotactile communication frequency, location, pattern, and duration to allow a user to recognize tactons representing basic mathematical symbols most accurately? How much mental effort is required to use a hand-centric haptic interface for basic mathematical symbols? To communicate algebraic equations, we leveraged the Nemeth Braille code for mathematics shown in Figure 1, and we developed a pair of gloves with embedded vibration motors to facilitate the tactile communication of these characters. We conducted an initial perception study with 6 participants to find the optimal configuration of vibration motors. Participants were asked to first recognize 5 randomly generated mathematical symbols followed by 10 simple algebraic equations. This was done for each location, proximal, intermediate, and distal, with a random vibration and overlap pattern at each location. Through this study, we found that using haptic vibrations at 20 Hz with no overlap in the posterior distal position gave participants the clearest signal. We conducted a second study in which we surveyed 4 visually impaired individuals to understand the best form of input to navigate through an equation while solving it. Users preferred a finger input combination for scale changes, but had no consensus on the type of input for going to the previous line and changing the cursor movement. To be consistent, we used a finger input combination for all forms of input. Finally, we conducted a pilot study with a blind user during which they were asked to solve 7 simple algebraic problems using the haptic gloves. Overall, she thought the system was intuitive and had excellent potential. Although she rated the mental effort required to use the gloves as high, the time it took her to answer questions decreased as she became more and more familiar with the gloves. Overall, we found that our haptic gloves were an intuitive and promising means of aiding BVI individuals in understanding, navigating, and entering in solutions to simple algebraic problems.